In a survey of 9,000 women, 6,431 say they change their nail polish once a week. Construct a 90% confidence interval for the population proportion of women who will change their nail polish once a week. Well, we're going to start out by using the definition of the confidence interval for a population proportion P, and we're going to use this as our definition, and we're going to define the variables. Okay, first off, n is going to be the sample size. Our z sub c, that's going to be our critical value that corresponds to our given level of confidence. E is going to be the margin of error. And then we'll talk about p hat and q hat. P hat will be our point estimate for the population proportion of successes. So this is going to be point estimate. And as I said, that's going to be successes. And then we'll have Q hat, which is also going to be a point estimate, but it's going to be the proportion of failures. And you'll obtain Q hat by subtracting P hat from 1. Notice though that we need to make sure that our P hat and our Q hat are in decimal format. So let's start by defining n. In this particular case, n is 9,000. We're also going to define x, which is going to represent the number of successes, which in this case will be equal to 6,431. Therefore, p hat is going to be the ratio of the number of successes to the total number of trials, or the total number of women that were surveyed for this. And this will be equal to 0.71455, which I will then round to 0.7146, which represents 71.46%, but we will leave it as a decimal. Then we want to define Q hat, which will be equal to 1 minus P hat, which is equal to 1 minus 0.7146. And that will be equal to 0.2854. We also want to confirm that we can use the normal distribution, or that it can be approximated by the normal distribution. And we'll have to use the fact that 5 must be less than or equal to n times p hat, which will be equal to 9,000 times 0.7146. Another way of looking at that is the fact that we could write NP hat must be greater than or equal to 5. Either way we look at that, we still are going to be multiplying 9,000 by 0.7146, and we want to question whether or not this is greater than or equal to 5, so I'll put a question mark above it until I do the actual calculation. Once I do that calculation, then I can remove the question mark if it's a true statement, and remove the question mark if it's not a true statement, and determine which way I'm going to go. So 6,431 is greater than or equal to 5. This is a true statement, so we can use the approximation of the normal distribution for P hat, but we also want to do it for Q hat too. And we're going to do the exact same thing. So we will go ahead and calculate n times Q hat and confirm that it is greater than or equal to 5. So remembering that n is 9,000, we'll multiply that by q hat, which is 0.2854. Once again, I want to know if that's greater than or equal to 5. So we go ahead and multiply 9,000 times 0.2854, and we'll end up with 2,568.6, and that is definitely greater than or equal to 5, and that will be a true statement. And I apologize, I had written a less than or equal to sign there. It should have been greater than or equal to. Not sure why I reversed it. But in either case, I see that I can use an approximation by using the standard normal distribution. So now I need to go ahead and calculate z sub c. And this is going to be z sub c for a 90% confidence interval, which I will abbreviate as C dot I dot. So I need to go into the standard normal table and I need to look for that value. Unfortunately, table 4 in our textbook does have this quick and handy reference, and we'll note that level of confidence C, in this particular case, we are at a 90% or 0.90. That is going to indicate that our z sub c is going to be 1.645, and we will use that in our calculations. Now, I always try to tell students to hold off on doing your complete calculations until the very last part, if at all possible, to mitigate round-off error. So we're going to use our confidence interval formula, and remembering that n is equal to 9,000, p hat was calculated to be equal to 0.7146, q hat was calculated to be 0.2854, and we also note that our z sub c is equal to 1.645. So what I'm going to do is just write this out, and we'll start with this side of the confidence interval. And this is what it's going to look like. On the left hand side, p hat 0.7146 minus the error, which will be given as z sub c 1.645 times the square root of the product of p hat and q hat 0.7146 times 0.2854 all over n, which is 9,000. Likewise, we will have basically the same thing on the right, except instead of a subtraction sign, it is a plus sign. Calculate this by plugging this all into your calculator. I try to emphasize that this will mitigate round-off error, and let me show you how to use this on a web-based calculator called Calc 2.0. So this is the calculator. It's web 2.0 calc.com. You can see the URL. Sorry about that, is right here. Okay, now what we're going to do is just type in this side as it's stated. And let me show you how that's going to work. Okay, so let's type in 0.7146, and you can use your keyboard or you can use your mouse to control this. We're going to subtract, and then we're going to type in 1.645. We're going to multiply by the square root. We're going to use this key right here, or we could type in SQRT, and you'll notice that it puts it there. And then we're going to type in 0.7146. We're going to multiply that by 0.2854, and then we're going to divide that by 9,000. Notice that I need to close this parentheses that starts here, over here, and you'll notice that up top in this area, it is exactly the same thing as what I have written down. So now we press equals, and we end up with this following number, and we really only need to go these 5 digits here to look at it, but I believe the problem says round to the nearest third digit or to 3 decimal places, so we'll take these 4 and we'll write it as 0.707. So we have 0.707 less than or equal to P, less than or equal to, and we're going to do the same thing for the right hand side. And you'll notice that I have the exact same thing entered, except instead of a subtraction sign I have this addition sign. Left click equals, and this is going to give us 0.7224, but we'll just take it as 0.722. This is your confidence interval, which we can then write as 0.707 or 707, comma 0.722. We'll close those in parentheses. Now, when you're doing your homework, there's going to be a little bit of fudge factor within my math lab or my stat lab. It's usually going to be within plus or minus of either one of those. I believe in the textbook or in the actual homework assignment, the answer would have been this. And that simply is due to differences in rounding off. But that's how the problem is approached.